Alright, so let's get into this full Desmos tutorial. So the first page is when do you want to use it? So on the SAT, you don't want to use it for every single question because sometimes it's just going to slow you down. So if it's like basic algebra, like 60% of 100 or something basic, there's no point in using Desmos. It's just going to slow you down. You're going to lose time. Same thing with systems of linear equations. Never use it for geometry. Okay, for geometry, it's always faster to just do it by hand. You're going to understand it so much better if you just draw it out. And for word problems, well, that's like situational. If it's like simple word problems, there's no point in using Desmos. Okay, so don't rely on Desmos too much. Make sure you trust yourself. But when do you use it? If you ever see a table, straight to Desmos. If you see systems of nonlinear equations, we'll go over that. Quadratics, Desmos is pretty good at this. Constants, I'm talking like the A, B, C, all that stuff, go straight to Desmos. Some of them are going to be really hard to do on Desmos, and for those, I better do on paper. Systems of inequalities, if you see greater than, less than, and equations, you're probably better off doing Desmos. Mean, median, statistics, you don't really see a lot of this now, but it's still, you can still do it on Desmos. And then the final one is nested functions and percentages. We'll go over that. Okay, so let's do the first one, is tables and regressions. Okay, this is going to be a little complicated to explain, but you need 1 point more than the power. So a linear equation is like x to the first power, right? And if it's x to the first power, you're going to need 2 points to do that. Now quadratic is x to the second power. You're going to need 3 points to be able to get a regression out of that. Okay, cubic is 4 points, but you don't really need no more than quadratic. So let me show you an example of that so that you guys can know what I'm talking about. And sometimes you're going to need to infer points. We'll go over that too. So here's our first thing. So x, and then we have a table, and then 3 values, g of x equals f of x over x plus 3. The key thing here is x is a linear function. So what is the y-intercept of the graph of f of x? Okay, let's go into Desmos, right? So here, we can start by putting in a table, right here. Table, first point, negative 27, and that's 3, 0, 5, negative 9, 21. Okay, negative 9 and 21. So to do a regression, you see this y1, x1, that's what we're going to use. So y1, and then instead of an equal sign, we're using a tilde of x divided by x plus 3. Well, x1 plus 3, right? And now we know f of x is a linear equation. And what's the equation for linear equation? It's mx plus b, right? So we're going to come in here, and we're going to do mx1 plus b. And there we go. M equals 4, b equals 36. Here's our equation for f of x equals mx plus b. And what are we looking for? We're looking for what is the y-intercept. So we'll just scroll out from here, 36, back, and the answer is going to be 36. Okay, so it's pretty simple. You just need to know what you're looking for and then write it out as you're looking for it. Okay, next question. A ball is thrown and reaches a maximum of 36 meters high after 3 seconds. Okay, I wrote this myself, but the key point is like, you're going to see questions like this. I couldn't find one, but it's there because I had it on my SAT. A ball is thrown and reaches a maximum of 36 meters after 3 seconds. Okay, so in word problems like this, our seconds is going to be our x, time x. So come here and make a table. So 36 and 3, right? That's 1 point, our maximum. And then after 9 seconds, it hits the ground. So 0 and 9. If you remember, quadratics are always symmetrical. They're always going to be symmetrical. So I wrote this backwards. My fault. 36, 3, 0, 9. Okay, but they're always going to be symmetrical. So if it comes here and it hits here, this distance is the same from the next 0 point. Do you know what I'm saying? So from 3 to 9 is 6. 9 minus 3 is 6. So the other root is going to be 3 is 6. So negative 3, 0. And now that we have 3 points, we can do a regression. And that's going to be y1 equals a x1 squared plus bx1 c. And there's our values. And what are we looking for? We're looking for the height from which it was thrown. So the y-intercept. So t equals 0, time equals 0. It was thrown from 27 meters high. Okay, the big part here is being able to like know the point that you're missing. You can do maximums, or you can look for the other 0, which is what I did here. So you know that this is the maximum, there's this much distance. The other one has to be symmetrical, so that much distance away. Okay, the next one, the function is defined as this, and it has an x-intercept here and a y-intercept here. What is the value of b? Okay, let's go back. And let's start with another table, and let's put in our points. So an x-intercept of 2, 0, so 2, 0, and a y-intercept of 0, negative 323. 0, negative 323. Now we can do a regression with this, but we don't want one of these basic regressions, right? So you're gonna come down here, y1 equals a, make sure to check, a to the power of x1, b. And we're gonna get a is 18 and b is negative 324. We can come back. What is the value of b? Right there, negative 324. There is another way to do this, which is recognizing the y-intercept is when x equals 0, plug in 0. So 1 plus b has to be negative 323. So b has to be negative 324. That's how I would do it, but Desmos is just as fast if you need to. Okay, next thing, quadratics. Okay, these three formulas you're not going to see in like other places. Obviously, this is your quadratic formula, but know these. Your vertex is a negative b over 2a. Your sum of solutions is negative b over a. Your product of solutions is c over a. And then f of 1 is a plus b plus c. This one is like just like a 1 squared plus b times 1 plus c, but it's useful on some questions. So let's go into a practice question with these. A machine launches the softball from ground level, reaches the maximum height of this after this seconds, and then hits the ground at this time. Okay, which equation represents the height after t seconds? Right? So remember, you want to look at these equations. What am I doing? My fault. Okay, these equations right here. Okay, so this is your vertex form. X. This is not Desmos, this is off topic, but x minus h, so where h is your x and k is your y for your vertex. So with that, we can just see that it has to be the highest point is 51.84, vertex form right there, 51.84. This is going to be your answer. But, and then the x-axis right here. So we can narrow it down. It's not this, it's not this. It has to be one of B or D. And B doesn't have the minus 1.8 and D does, so it's D. But you can always graph it if you're not sure, okay? What we would do here is you would come to the Desmos and you would put in your 2 points, 31.8, 31.84, 51.84, 1.8, and 51.84. And then you're reaching 0 after 3.6 seconds. And it started from ground level, so another 0 at t equals 0. Now that we have our 3 points, we can do a regression. And we're looking for vertex form because all the answers here are in vertex form. So it's a has x minus h squared, okay? And don't forget to put the 1 after your x. And you'll see that it's x1 minus 1.8 squared plus this, and a is negative 16. And that lines up with D. Okay, next question. For what value of x does it reach a minimum? Okay, this one, it's just you're looking for the minimums, you want to graph it. And we can type it out like you give us f of x equals x minus 44 and then minus 46. We're looking for a minimum. What value does it reach? 45. Of course, you can know that it's symmetrical, so between 44 and 46, 45. But yeah, and that's how you do it, minimum 45. All right, so let's go with systems of nonlinear equations. Okay, I forgot to do this, but y plus k equals x plus 26, and then y minus k equals x squared minus 5x. So in the system of equations, k is a constant, and it has one distinct real solution. So what does that mean? It means they only intersect at one point, right? But what that also means is we can't just make it a regression, because it's only going to intersect at one point. So if you make it a regression, that means it's true for all x's, and it's not. So what we're going to do is we're going to turn them into equations that we can graph. Okay, so let me start out by drawing our equation. So we have y equals plus 26 minus k, right? Other one is y equals x squared minus 5 plus k. So let's go into our thing and let's write it out. So y equals x plus 26 minus k. Last one is y equals squared minus 5x plus k. Let's add a slider for k, okay? And I'll zoom out so that we can see what we're looking at. And we want this line to intercept this thing at only one spot. So we'll zoom out, okay? It needs to keep getting bigger. Let's say 20. Keep zooming out, and we just passed, right? We want this to be intercepting at about 1 point. So we're gonna start bringing it down. 17.5. Let's zoom in. The wrong spot. Let's see if we see any where they combine. Right there. See the dot? It's combined. It's connecting there. If there's a white dot, it means it's something happening there. And as we just saw, there is in fact white dot there. So it was connecting at 11.5, right? 11.5. So that means that 17.5 is our answer for only one real solution. Remember, if you make it smaller, then we're gonna get multiple solutions, which is not what we want. See, and if you make it bigger than 17.5, we're not gonna be touching. But 17.5 is touching at one spot. So answer is k equals 17. Okay, so solution. Let's do this question. So the constants. The solution to x squared plus 6x plus 7 equals 0 or r plus s, where r is less than s. Solution to this is t and u, where t is less than u. The solution to this, where c is a constant, is r plus t and s plus u. What is the value of c? Okay, if you're going to do this by hand, this is a mess. So let's do it in Desmos. Okay? Oops. Okay, let's do it in Desmos. So what are we looking for? The solutions are r and s, right? So what a solution is when x equals 0. So first we'll start at the equation. Squared plus 6x plus 7. Right? And we're going to come here and we'll get the point, and that's equal to r, right? So r equals this x value. We'll get rid of the comma 0. And then we know that s equals this x value, right? So equals there. We get the comma 0. So there's where s and r are. And I'll find t and u. So t, so x squared plus 8x plus 8 squared plus 8. And let's find t and u. So t is this one right here. So t equals this out, and then u equals this one right here. Make sure. Yeah, this one right here. So u is equivalent to this. And we can make sure because t is less than u and s, r is less than s. Makes sense. T is less than u, r less than s. And we're looking for what is the value of c when when the solutions are r plus t and s plus u. So what is the solution? It's when when y equals 0, right? So we know that r plus t, was it t? Yeah, r plus t is 0 and plus u is 0. So what is c? Now we know that y1 is equal to, let me move my face out of there, is equal to x1 squared, getting 14x1. Remember, the x1 is just there because it's a regression, plus c. And there we go. C is 31.000001. That's 31. So just put 31. And that's how you do that on Desmos. That's a real mess if you're doing it by hand. It's a mess on Desmos too, but it's way worse by hand. And okay, the next thing, mean, median, standard deviation. So anytime you see mean, median, standard deviation, you can just do it like this. I don't have a question for this really, but that's how you would do it. Just type it out, put the numbers in between, and there you go. And the last one's functions. If function g is defined by this, what is the value of g at 3? You can just plug in 3 here. 24, 25, square root of 25 is 5. But I'm just trying to show you that how to do it on Desmos. For that one, you would just do it by hand. But we can say g of x equals the square root 8x plus 1. And then you can just come in here and write out g of 3, and it's 5. So that's going to be useful right here. G is defined by g of x equals absolute value of x divided by a minus 14, where a is less than 0. What is the product of g of 15a and g of 7a, right? So we'll come here. G of x equals absolute value bars divided by a of x, and it's minus 14. That's 14. And we can just add a slider a, and what does a have to be less than? A has to be less than 0, so we'll make it less than 0. And so what is g of 15 and g of 15a times g of 7a? 609. And we can drag it around and make sure the number doesn't change no matter what a is. If you get bigger than 0, then it's going to change. It's going to become different, but you're looking for less than 0. So the answer is 609. And let's go to the next one. So again, it's a plus 5. You can know it's a shift left 5 and just find the minimum, but it's so much easier to do it on Desmos. So first out of this equation, fx equals 4x squared plus 64x plus 262. X equals, okay, I already forgot it. Oh my god. 4x squared plus 64x plus 262. And now we know that g of x equals f of x plus, right? And what are we looking for? We're looking for the minimum. So if blue is our g of x, we're looking for the minimum. And for what value of x does it reach its minimum? Right there, negative 13 is the answer. Okay? And systems of inequalities, I'm not really going to do this, but if they say what point lies between this inequality and this inequality, you can really just graph out the first inequality, second inequality, look, and then plot your points. It'll be like, oh, that one's in the point, that one's not. That's how you would figure it out. Okay. Percentages. So, percentages, you can save so much time on this. If you do it by hand, it's going to be a pain, but I'm going to show you a quick trick. So you're going to come in here, and you're going to make 2 square brackets and set them equal to each other. And what a square bracket is, like multiple functions. So you could say say a plus b equals 2. And then at the same time, b minus a equals 5. There we go. There's a and there's b. So it's saying that both of these things are true. How can we use it for percents? So we can restart with the 2 square brackets. And okay, A is 540% more than B, meaning it's 540% plus 100% of B, so 640% of B, right? So you can come back here. A is 640% of B. You can hit the percent sign, it'll do that. Now, we're going to come back. B is 0.02% of C, not more than, of C. So, comma 1, comma 2 to make our second terms. B is 0.02% of C. And then our last term, A, is K% of C. So, A is K% of C. And K is 0.128%. You don't need to multiply by 100 because it's already in percentages. Okay, and okay, this is the last slide. So for geometry, it's always best to just draw it out on paper. It's going to seem counterintuitive because the entire video is about Desmos, but when it comes to geometry, you're never going to understand angles and lines until you're actually looking at them. So in my opinion, it's best to draw on paper, but try it out for yourself and see what works best. So yeah, that's everything, and that's how you're going to use Desmos to solve your problems on the SAT that's coming up.